Okay, in this video, we're going to talk about physiology of endurance and performance, and we're going to focus on terminology. Knowing your terminology is critical to this class. It's critical to doing well on the exams, and it's critical to be able to talk to each other about endurance performance, as well as to talk with athletes and other people out in the community involved with endurance performance. So let's talk a little bit about uh, the terms that we'll see this semester. You're in the Department of Kinesiology and Nutrition Sciences. I've got kinesiology defined here. You should know the definition of kinesiology. Kinesiology is the scientific study of human movement. It's good to have that down. You've been taking classes throughout your undergraduate experience that are focused on understanding different perspectives of human movement, whether that be motor learning, exercise physiology, biomechanics, anatomy and physiology, psychology, whatever it is, the courses that you've taken are all related to the scientific study of human movement. This is a class on physiology of endurance performance. So what's physiology? Well, physiology, if you look this up in Taber's Medical Dictionary, is simply defined as the science of the functions of the living organism, in this case human, and its components and of the chemical and physical processes involved. So a human is what we're interested in because we're dealing with human performance. What's the definition of a human? Well, we can look that up as well. Just from dictionary.com, human is defined as people, a member of a species, Homo sapiens. Okay, so in kinesiology, we have classes on exercise physiology. Well, exercise physiology is defined as a basic and applied science that describes, explains, and uses the body's response to exercise and the adaptation to exercise training to maximize human physical potential. That just comes from a textbook by Plowman and Smith. All right, so that is a definition of exercise physiology. It's the physiological responses to exercise, or during exercise, or after exercise, or before exercise, but something related to exercise. This class is focused on endurance, so it's important to have a definition of an endurance so we can understand when we're talking with each other about endurance performance. If we look up just a dictionary definition of endurance, it's the ability to sustain a prolonged stressful effort or activity. Hopefully, this class is not a long, sustained, prolonged, stressful effort or activity. What we are talking about here is endurance of human performance. So any event, any movement that is sustained, it's prolonged, there's some type of stress involved for the activity. In this case, our activity is swim, bike, or run. Performance. Okay, and I'm going to go through this in a little bit more detail later. Performance is, so we're doing physiology of endurance performance. Performance is the execution of an action or something that's accomplished. I'll give you a little bit more information on this in just a bit. All right, so physiology of endurance performance, there's a lot of different concepts that we will cover and that you're going to need to know. As you start reading the textbook, read chapters 1, 2, and 3, and 4, you identify the concepts. Sometimes you'll need to go to a textbook to understand the concepts a little bit more, or Taber's Medical Dictionary is an excellent resource. But the important concepts that we will be talking about during the semester include running economy, aerobic power, anaerobic power, VO2, rate of oxygen consumption, VO2 max, maximal rate of oxygen consumption, heart rate, power, heart rate, VO2 relationship or relationships, lactate threshold, anaerobic threshold, ABLA, onset of blood lactate accumulation, ventilatory threshold, lactate turn point. We need to know the Fick equation, thermoregulation concepts, hydration strategies, fueling for, during, or after endurance events, and fatigue. All right, these are all different concepts that we need to have an understanding of as we progress through this semester. All right, so let's go into this a little bit more. Endurance, the ability to withstand extraordinary mental or physical stress for a prolonged period, right? The ability to continue despite pain, fatigue, or stress, right? This is our endurance event. So a marathon, an Ironman. And we will at times talk about the mental stress of doing an event that lasts 8 hours, 10 hours, 17 hours. All right, marathon, 26.2. The elite finishers, about 2 hours. This last year, we saw someone, Eliud Kipchoge, go under 2 hours. Of course, there's a little bit of help with drafting and pacing and so forth, but still really phenomenal. Mere mortals, if you do a marathon in 3 hours, that's fantastic. Maybe it's 4 hours or 5 or maybe even 6 hours. That's still really impressive, and that is an endurance event. Ironman, that we're going to talk about a lot, or Iron Distance event, a more generic way to refer to that. A swim of 2.4 miles, bike 112 miles, and run 26.2, a marathon at the end. All in one day. Elite athletes, sub 8 is pretty common now with the pro men. 8.5 hours for females, 8:20. Mere mortals, MN, 11 to 16 hours. Most races will give you 17 hours to complete. And if it takes you longer than 17 hours, you're not considered a finisher, unfortunately. But can you just imagine doing an event for 17 hours where all you're eating or drinking are things like Gatorade or Powerade or whatever sport drink is on the course, and all you're eating are Snicker bars or whatever candy, carbohydrate is available, goos or what have you. Obviously, I'm kidding about that candy bars, but actually a lot of people do eat candy bars during these events. But can you imagine just eating a Snickers bar for breakfast, lunch, and dinner, or multiple Snicker bars? That your stomach would be pretty upset by the end of the day. We need to talk about that because that is an endurance event that's pretty amazing to do. Okay, physiology. Again, just applying it to this class, the science and a function of living organism and its components and chemical and physical processes involved, the basic and applied science that describes, explains, and uses the body's response to exercise adaptation. I'm repeating myself here, but that's our key term here. So in our physiology, we will talk a lot about power during biking. We'll talk about heart rate during running, biking, and swimming. Heart rate's a little harder to measure during swimming, but there are some neat tools that have just come out this last year or so that allow us to measure heart rate during swimming. So we'll talk about the physiology. We're talking about field 2, rate of oxygen consumption, and we'll do things like we're talking about graded exercise tests, which just illustrates this is rate of oxygen consumption on the y-axis, mLs of oxygen per kilogram body mass per minute, and down here is time. And over time, the amount of work that the person's doing, the intensity of exercise is increasing as illustrated by this light blue line. The step is incremental. So it's an increase in resistance during biking. And then this line here represents the heart rate that increases pretty linearly with increases in intensity. And eventually the person stops, all right? And the heart rate drops a little bit right here, but the work, their intensity drops off to 0 here. And then this red line represents rate of oxygen consumption throughout this graded exercise test. And then down here, we have rating of perceived exertion, or how hard the person feels the exercise is. And we really want to understand this red line, this rate of oxygen consumption. In the field, we have to measure something more simple and look at heart rate. But we can see that VO2 and heart rate here increase throughout this time period, and we'll use one to predict the other. And we'll talk about that more during the semester. So this is our physiology. So performance, well, what's performance? Well, if we look at these terms, structure, function, and performance, and I'll do another presentation on these 3 parameters specifically. Structure is just the arrangements of the parts of the whole. It's the bones, it's the muscles, it's the muscle cells, it's the circulatory system, it's the nuts and bolts of, in this case, the human body. Function is the normal characteristic or action. Our muscles contract concentrically, eccentrically, isometrically. Our heart beats. There's a flow of blood within the system. And performance is functional effectiveness, or how well something functions, how well the heart pumps blood out into the system, how well the lungs oxygenate the blood, how well the muscle contracts to generate a force. Right? So that's how well we do something. Right? These terms are all important to understand, to talk with the community members, talk with each other, and it is important to use terminology correctly. So how do you do this? Well, as you read the book, as you read a paper for your project, write down key terms in real time. So what I do is, as a habit, I'll be reading a paper and I'll have another piece of paper next to me. I'll be reading a manuscript and I'll jot down terms that I want to make sure I understand. And that's a great exercise for you to do when you're going through the textbook or when you're reading a manuscript that you're going to use for your project. Make sure you can define these terms. Make sure you can provide an equation when it's appropriate, and make sure that you can state the units of the particular parameter or concepts that you're talking about. When you do this, it helps us that we can have a conversation when we're talking about power or VO2 or fatigue. Some of these terms are nebulous and hard to define, but we can only talk about them when we do state a definition and some of the details behind the parameter. Okay, so that's my pep talk for knowing terminology. Thanks.